morning. So we have discussed in the last class about chain rule and total derivative. Now in this class we are going to discuss Euler's theorem. So how to solve a problem, how to verify by Euler's theorem. So first of all, to discuss about Euler's theorem, first of all we have to discuss homogeneous function. So what is the homogeneous function? Suppose the function f of x comma y, for example here function f of x comma y is said to be homogeneous function of degree n. Homogeneous function of degree n if there exists here f of kx comma ky is equal to here k power n into f of x comma y. So that means, so in given function replace x and y with kx ky, then we get k power n into f of x comma y. So in this case the function f of x comma y is called a homogeneous function of degree n. So here we have two variables, for three variables also. So for example, f of x comma y comma z is a homogeneous function of degree n. So if f of kx, ky, kz is equal to, so right, so k power n into f of x, y, z. So in this case then given function f of x, y, z is called a homogeneous function of degree n. This is the homogeneous function. Next one. Now Euler's theorem. So what is Euler's theorem? So statement of Euler's theorem. Euler's theorem. Now here Euler's theorem is suppose f of x comma y, f of x comma y, or z is equal to f of x comma y is a homogeneous function of degree n. Z is f of x comma y is a homogeneous function of degree n if x into dou z by dou x plus y into dou z by dou y is equal to nz. So this is the statement of Euler's theorem. So here z is the function, so then z with respect to x, z with respect to y, then x dou z by dou x plus y dou z by dou y equal to nz. So what is n here? N is the homogeneous function of degree n, right? So this is Euler's theorem. Now take one problem. So then how to verify Euler's theorem by given one, right? First of all take one problem. So verify Euler's theorem for, so here function is u is equal to x square tan inverse of y by x minus y square into tan inverse of x by y, right? So this is the function. Verify Euler's theorem for this function u. So what is Euler's theorem? Actually suppose the z is the function, then Euler's theorem is x dou z by dou x plus y dou z by dou y is equal to nz, right? Here the function is u. So now first of all write given one. So given u is equal to, right, tan inverse of y by x minus y square tan inverse of x by y. First of all, what is the function of degree? So to check homogeneous function, first of all, this is u of x comma y, then write u of kx ky. U of kx ky is k power n into u of x comma y, then that is a homogeneous function of degree n. Now here write, in place of x and y, kx ky. So that means here u of kx ky. So what we get here? So kx x square, kx whole square, that means k square x square into tan inverse of ky by kx, then we get same function here, right? Minus here y square. What is y? Y is ky, then write k square y square, then take k common k square. So here we get tan inverse of, again replace x and y with kx ky, then we get xy, x by y. So finally, so what we get here? So here k square into, so x square tan inverse minus y square tan inverse is the given function u. So that's why here this is now u of kx ky is k square of u of x comma y. That means, so here k power 2. So that's why here the function u is a homogeneous function of degree 2. So clearly u is a homogeneous function of degree 2. So here homogeneous function of degree is 2. Now by Euler's theorem. What is Euler's theorem? By Euler's theorem, here Euler's theorem is, what is Euler's theorem for the function u? Now write x dou u by dou x plus y dou u by dou y is equal to n into u. N is the homogeneous function of degree. So what is n here? N is 2. So that's where, right. So this is equation 1, right? So after checking homogeneous, we get x dou u by dou x plus y dou u by dou y is equal to 2u. Now to verify Euler's theorem. So how to verify? So now find dou u by dou x, dou u by dou y. After that write x dou u by dou x plus y dou u by dou y is 2u. Then it's clearly theorem is verified, right? So that's why take, first of all find dou u by dou x and dou u by dou y. Now function u is equal to, what is the here? What is the function here? X square tan inverse y by x minus y square tan inverse x by y. This is the function. Now calculate dou u by dou x and dou u by dou y. Right here u with respect to x, dou u by dou x. So this is the function. Here with respect to x, so in this x square, in this function also we have x square. So that's why take uv derivative. What is uv derivative? So now here u into x square into derivative of tan inverse of y by x. What is the derivative of tan inverse x? So derivative of tan inverse x is, so here write derivative of tan inverse x. What is the derivative? Here derivative is, so 1 by 1 plus x square. So tan inverse x. Now here tan inverse of, this is considered as some x. So that's why write derivative of tan inverse x is 1 by 1 plus x square. So in this function we have in place of x, y by x. So that's why 1 by 1 plus x square. What is x here? Y by x whole square, and again derivative of, so here derivative with respect to x, so derivative of y by x, right? U into derivative of tan inverse y by x is 1 by 1 plus x square, and into derivative of here y by x plus v u dash, u v dash plus v u dash tan inverse y by x into x square derivative. What is x square derivative? So x square derivative is 2x. So tan inverse of y by x. So this is the derivative for this function, right? Now minus y square into tan inverse of x by y. Here again, so here with respect to x, then what is constant? Y square is constant, right, as it is. So now tan inverse of x, tan inverse x derivative is 1 by 1 plus x square. In place of x here, x by y, and again derivative of x by y, right? Now from this, so here take LCM, so x square plus y square by x square. Now take into numerator, so here x square, again we get x square by x square plus y square. After simplifying this, we get x square by x square plus y square into here dou by dou x of y by x. So in with respect to x, then what is constant? So y is the constant. Now 1 by x derivative is minus 1 by x square, right? Plus 2x tan inverse y by x minus, so here again simplifying this, take LCM, y square plus x square by y square, take into numerator, already here y square, then again we get y square by x square plus y square into derivative of x by y with respect to x. So with respect to x, then what is constant in this? 1 by y is the constant. Here 1 by y derivative of x is 1. Now here, so x square cancel, so finally what we get x square into minus y, so that's why minus x square y by x square plus y square for this function. Now minus plus 2x tan inverse of y by x, this function. Now here again y square y, 1 y cancelled, finally we get y cube by x square plus y square, right? So this is dou u by x. Again simplifying this, now here minus x square y, here minus y cube, so take y square common. So first write here when dou u by dou x value is, so first write positive term 2x tan inverse of y by x, right? Write this term, then again take common minus, what is common value? So y is the common, so y into, so in numerator we get x square plus y square by, again here denominator we have x square plus y square. So from this expressions, right? Now here 2x tan inverse of y by x, here x square plus y square, x square plus y is cancel, so finally we get a y. Now to calculate x into dou u by dou x, then multiply with x dou u by dou x, x dou u by dou x, then multiplying with the x, simply write here we get 2x square tan inverse y by x minus xy. So this is x dou u by dou x plus x dou u by dou x value, right? Similarly we can find y dou u by dou y. So first of all, what is dou u by dou y, right? Here dou u by dou y is u with respect to y. So what is u? Here u is x square tan inverse y by x minus y square tan inverse x by y. Now write dou u by dou y. Here dou u by dou y with respect to y, what is constant? So x square is the constant. Write here x square. Now tan inverse y by x with respect to y. So tan inverse x derivative is 1 by 1 plus x square. So here in place of x we have y by x into again derivative of y by x with respect to y. So with respect to y, so 1 by x is constant, y derivative is 1. Next minus, so here y square tan inverse x by y. So here in two functions we have y. So now take uv derivative is, so y square into tan inverse x by y. So tan inverse x by y is 1 by x 1 plus x square again derivative of x by y with respect to y. So x constant, 1 by y derivative is minus 1 by y, minus 1 by y square, right? So x into minus 1 by y square, u v dash, so u into v dash plus v u dash. Now here minus, then again we get a minus, so y square derivative 2y tan inverse x by y, right? Simplifying this, here we get 1x cancel, here take LCM, x square plus y square by x square, finally we get x cube by x square plus y square, right? So x cancel, I am taking x square plus y square by x square, take into numerator x square, here we have x, so then that is x cube, right? Minus, here also 1 y square, so y square cancelled, so simplifying this x square plus y square by y square, take into numerator, so here minus minus of minus plus, okay, then y square by x square plus y square, so from these two, next minus 2y tan inverse x by y, right? Now what is common in these two? So again here also we have x, now take x common, finally we get x square plus y square by x square plus y square, from these two minus 2y tan inverse x by y, okay. Now this is the dou u by dou y, now multiply with y dou u by dou y is equal to, so here multiplying with y, here we get xy, so this is cancelled, right? X square plus y square, x square plus y square cancelled, so we get xy minus 2xy, 2y square, sorry, 2y square multiplying with y, 2y square tan inverse x by y. Now this is the y into dou u by dou y. Now so this is from these two, x dou u by dou x plus y dou u by dou y, adding these two terms, so what we get, adding these two terms, x dou u by x dou u by dou x plus y dou u by dou y. Now here x dou u by dou x is this one plus y dou u by dou y is, adding these two, so 2x square tan inverse of y by x minus xy, that is x dou u by dou x plus y dou u by dou y. So y dou u by dou y is here xy minus 2y square tan inverse of x by y. Now here xy cancelled, so in this 2 is the common value, take 2 common, so finally we get x square tan inverse of y by x minus y square tan inverse of x by y, right? So from the given function, now what is the value, x square tan inverse minus y square tan inverse, this is the given function u, so that's why we get 2u, right? Now x dou u by dou x plus y dou u by dou y is 2u, again from we get equation 1 also same, so x dou u by dou x plus y dou u by dou y is 2u, so these two are equal, then clearly theorem is verified. So what is the theorem here? Euler's theorem. So Euler's theorem is verified, right? Now similarly we can find remaining problems also. For example, u is equal to sin y by x, sin inverse y by x plus tan inverse y by x. So we get remaining functions also, right? Now we are going to discuss one more problem. Now what is the problem? If u is equal to, if u, what is the function here? Tan inverse of x cube plus y cube by x plus y. If u is equal to tan inverse of x cube plus y cube by x plus y, then prove that x dou u by dou x plus y dou u by dou y is equal to sin 2u, is equal to sin 2u. Right? This is the problem. If u is equal to tan inverse of, given problems here, functions of tan inverse, cot inverse are logarithmic functions. For every functions we have to use here we have to prove that x dou u by dou x plus y dou u by dou y is equal to sin t. What is the x dou u by dou x plus y dou u by dou y? This is the Euler's theorem. So compulsory we have to use Euler's theorem. Now first of all, to use Euler's theorem, first what is the function here? So it is a homogeneous function or not? So consider this one. So here u is equal to, the function is tan inverse of x cube plus y cube by x plus y. Here clearly u is not a homogeneous. So మనం అబ్జర్వ్ చేస్తే ఇక్కడ క్లియర్లీ homogeneous function is not homogeneous, right? So if it is not homogeneous, now we take this one as so tan u is we can write tan u. So tan inverse of function u, tan u is equal to x cube plus y cube by x plus y, right? Tan u is equal to, now that implies here take take x cube common, in this x common. Now tan u is, this can be write as x cube into, now here this is 1 plus y by x whole cube by, in denominator x, take x common, so this can be write as 1 plus y by x. You can multiply with x and denominator, and you can multiply x cube with numerator, then we get same function x cube plus y cube by x plus y. Now in this x cube, 1x cancel, so finally we get x square into, this function is function of y by x. Now let it be sum phi of y by x, right? Now tan u is equal to x square into phi of y by x. Now it is considered as f. X square pi of y by x considered as f. Now in this, here function f is clearly homogeneous. So what is the homogeneous function? Just replace x with kx, y with ky. So here we get ky by kx, we get same function pi of y by x. Here x square means k square x square, that means k square into x square phi of y by x, and we get the same function. So that's why clearly f is the homogeneous function of degree 2. So finally here write f is equal to tan u from these two, right? So f is equal to tan u. Now clearly f is a homogeneous function of degree 2, right? Homogeneous function of degree 2. Now a homogeneous function of degree 2 by Euler's theorem. What is Euler's theorem actually? So x dou u by dou x plus y dou u by dou y is 2u, right? Now the given function, actually here function f is the homogeneous function. Now write by Euler's theorem by Euler's theorem for the function f. What we can write, f x dou f by dou x plus y dou f by dou y is equal to n into f. Here function f, so n into f, n is the homogeneous function of degree. So what is the degree here? 2 is the degree. That's why we write 2f. This is the Euler's theorem. But what is f? Here f is the tan u. Now write here x into dou by dou x of f is tan u plus y into dou by dou y of tan u is equal to 2 tan u. Just replace f with tan u. Now what is the derivative of tan u with respect to x? What is the tan u with respect to y? Now here derivative of tan u. What is derivative of tan? Derivative of tan is secant square. So that's why here write that implies x into tan u derivative is secant square u. So tan u derivative secant square u, and again u with respect to x. So that's why we write dou u by dou x plus. Now here y into what is y into tan u with respect to y. So tan u derivative again secant square u. So u with respect to y we get dou u by dou y, right, is equal to 2 tan u. Right? What is the common value in this expression? So secant square u is the common value. Here secant square u into, here we get x dou u by dou x plus y dou u by dou y is equal to 2 tan u. But we have to prove x dou u by dou x plus y dou u by dou y is sin 2u. So that's why we write this one. So x dou u by dou x plus y dou u by dou y is equal to, here 2 tan u, we have 2 tan u by, right, that is secant square u. Actually what is secant square? Secant square can be write as 1 by cos. So now write here 2, this can be sin u can be write as 2 sin u by cos u. 2 into tan u can be write as sin u by cos u. So here secant square u write as 1 by cos square. So 1 by cos square is so cos square u, reciprocal of 1 by cos square u. Now here one cos cancelled. So what we get? 2 sin u cos u. So but what is 2 sin u cos u? So that is clearly sin 2u. So now this is x dou u by dou x plus y dou u by dou y. So suppose given problem is just to find x dou u by dou x plus y dou u by dou y value, just we can find, if it is homogeneous function of degree, then directly write x dou u by dou x plus y dou by dou is nu, write in place of n, then what is degree here, right? But verify Euler's theorem. So to verify Euler's theorem, so we have to prove again x dou u by dou x plus y dou u by dou value and homogeneous function of degree. If two are equal, then theorem is verified. So these are the problems in Euler's theorem. Now in the next class we will discuss about Jacobian. So right, thank you.